So I am going to be looking at the standard 2ESS1, Earth's place in the universe. I chose this standard because I will be teaching second grade this upcoming fall. So in this standard, the students are learning about Earth's place in the universe. So they will use information from several sources to provide evidence that the Earth events can occur quickly or slowly. So these three colored boxes are the new NGS standards. There are the core dimensions of what we are looking for when we are teaching. So students will be using science and engineering practices, disciplinary core ideas, and cross-cutting concepts. These are discussed in this article called A New Look at the New Generation Standards. So these are in a circle, square, because they are connected with one another. So I imagine this as a ribbon, and this ribbon is never ending. So all three ideas are to help students come up with one overall idea. So in this standard, they're going to ask questions as who, what, where, when, why, and how to demonstrate understanding of key details in a text. So through the new standards, students will think critically about how can if Earth's events occur quickly or slowly. So in this article, this is the first part of what does science mean to you? So in this, it talks about another reason to teach science in elementary schools is to begin early to build scientific literacy. So learning to think scientifically and to understand the scientific view of the natural world takes time. So what this means is when they're in second grade, we would be reading it to them, but showing how things we do affects the world long term, short term, such as if we throw recycling in the recycling bin or if we throw things that can be recycled in the trash, how that makes a difference long term, or how we shut off the lights in the building or unplug our devices when we are not using them to save energy, how that affects it long term and short term. So students are able to make critical decisions such as, oh, I see trash on the road, I can pick this up because it will benefit the world in the long run, the short run. So they are thinking this because of scientific literacy. So they are using kind of all of these practices. So they're thinking of the ideas. In this second part of chapter 1, it talks about how the NGS standards are different from previous standards in many ways. And one that I thought that was great for this is K-12 science education should be reflected the interconnected nature of science as is practiced and experienced in the real world. So what I think of that is I think as the example of recycling or not recycling or shutting the lights off, because they learned this information in science and they are applying it in the real world. So looking at the dimensions, so these are the colorful boxes that were here. So I really like the asking questions and defining problems. So to figure out if something is happening slowly or quickly, we need to determine, what is their questions. So scientists always begin their investigations with questions. So they should ask questions of others about things and events they observe and wonder about, and then kind of tell the difference between questions and problems. So engineers begin their work with problems to solve. So if the students say, well, there's lots of trash on the ground, they can work with this problem by making sure they throw their trash in the trash bin. So this is more continued. So cross-cutting concepts. So what I found in this one was patterns. So if something happens slowly in the world, it's probably always going to happen slowly. Or if something happens very quickly, it's always probably going to happen quickly. So organizing and classification, say erosion. Erosion takes a longer time, as does global warming. However, a bird eating a straw, eating something that does not belong in their bodies, happens a little bit faster, so that could go, in a section where it's faster. Also, scale, proportion, and quantity. So that's just being, how slow is slow, how fast is fast. So it's really cross-cutting, like the ideas that we learn in math with science, and really thinking deeper about how it's going, how does it affect it, how long does it take to affect it. And then finally, the nature or disciplinary core ideas. So scientific knowledge is based on empirical evidence. So this means that scientific knowledge that they know right now as second graders is good knowledge that they have been told, or good knowledge they have observed. So it's not some random fact, it's stuff that is studied and is presented to them that is very evident that it is true.